So I'm just going to do a few problems to do with inheritance. I believe these are all blended inheritance problems that we'll see as we go. So first question, predict the phenotypic ratios of offspring when a homozygous white cow is crossed with a roan bull. So recall that this is one of those cases where this roan demonstrates codominance. Okay, that's the cow that is partly white and partly red or brown. We'll just call it red to make it simple. So, phenotypic ratios, that's what we want. Okay, we don't really care about anything else. We just want that answer. But we're going to have to do the rest to get to that answer. So, we have a homozygous white cow that is parent 1, and this roan bull is parent 2. Okay, so let's go over here. I'm going to set up my Punnett square. So, homozygous white cow. Remember, all of these alleles are dominant. Okay, this is codominant. So, I'm going to use the letter C to represent color. I'm going to have CW is white. This is the allele for white. And actually, this is something I would recommend you do. And CR is for red. Whenever you get to choose your own alleles, it's handy if you do just briefly, as an aside, just say what they are. Okay, so then it's not up to your marker or your examiner to figure out what you're doing. Okay, so now that that's done, that should probably be up here so I can see it in order, but never mind. Homozygous white cow. Homozygous meaning two alleles are both the same, so CW, CW. Okay, I'll just make that W a little bit clearer. Okay, cross with a roan bull. Now recall that the roan bull is that codominant phenotype. So CW, CR. Okay, so let's just do this cross here. This will be CW, CW. This will be CW, CRW. Sorry, CW, CR. Like I said, I'm not aware of any convention that says you have to put one of these before the other, given that they're both dominant. So I'm not going to worry about it. C, W, C, R. Okay, so remember, how we get phenotype is from genotype. Okay, so we start with genotype and then go to phenotype. This is one of those cases, I'll just leave that there. One of those cases where you could just, from this here, you could just say what the answer is. But if you are wrong, you will receive multiple penalties. Okay? So you'll get a tick for this, but if you go straight from there to your phenotype, you will lose some marks if you get this incorrect. So just like how you're always told to show your working out in mathematics, we're going to show our working out here. So the genotype is 2 CW, CW. Okay, so that homozygous white to 2 CW, CR. Therefore, 2 white to 2. Remember, this mixed one of this heterozygous phenotype is roan. Okay, the phenotypic ratios is 2 white to 2 roan, and I am going to simplify that down to 1 white to 1 roan. I'm sorry if my stylus is making a lot of clicks. I'm actually not sure what it sounds like. 1 white to 1 roan. Okay, and that's my answer there. Question number 2. What should the genotypes and phenotypes for parent cattle be if a farmer wanted only cattle with red fur? So I want the genotypes and phenotypes of the parents. Let's pick a nice color for this. Nope, not going to happen. Okay, this is what I want for the parents. And only cattle with red fur. So let's start by saying, what are the genotypes that will cause red fur? Okay, so genotype, I'm just going to write this. This is not any fancy biology way. I'm just going to write this out, how we do it in mathematics. Genotype for red fur. Options are C. Again, you should start by saying what your alleles are, because it's a follow-up question. I'll keep going. CR and CR. Anything else will result in white or roan fur. So that simplifies our next step a little bit. Since that's the only genotype we want to get that phenotype, there's really only one cross that can cause that, right? Because all of our offspring have to get two red alleles. They have to get a red allele from their mum and a red allele from their dad. And that sounds weird to say about cows. So the bull must provide 100% chance of getting a dominant red allele, and the cow, the mother, must also provide 100% chance of getting that, of giving those red alleles. So really, oh no, resume. So really, this is the only option we have. And why I'm doing a Punnett square is just to prove that. Okay, this is just my proof that the genotypes, both parents must be CR, homozygous for red fur. Phenotypes, I'm going to write CR with the red fur phenotype. And that's my answer. Okay, why? Because that's the only way you'll guarantee this. If any of these are different, I'll just make it the bull in this case. If this is white, then these, but this isn't the same as dominant recessive. Both of these are dominant, so even if they get one copy of that white, these are then going to both be roan, which is not what we want. Okay? So they have to all be red. Okay, that's answer number 2. Number 3, one of these multi-step problems. A cross between a black cat, let's highlight that so we know what we're doing, a black cat and a tan cat produces a tabby pattern. So black and tan fur together. I don't like that. I'm going to quickly Google what a tabby cat is. Because that's a very poorly worded question. Okay, this looks like it's a mix of, and a mix in that you're seeing both black and tan in or on the cat. Okay, so if you have a cat here, here's going to be I'm not an artist, this is my cat. You are seeing patches of black, and you are seeing patches of tan. This is probably the worst use of this technology I could think of, to draw a weird cat. That's actually not bad. So that's my cat. Now, what type of dominance or what type of inheritance does this illustrate? Well, I'm seeing both of these alleles being fully expressed at different times or in different places. So they're both expressing themselves fully. Okay? Because they're expressing themselves fully, it is not incomplete inheritance. Okay? Or incomplete dominance, sorry, because they are completely dominating. So this is question A. So how you write this is, since you are seeing, the traits being fully expressed in different places, therefore this is codominance. If this was just a one-point question, you would just write codominance. If it's explain or something like that, then you would need to have this little bit of an explanation before your answer. Okay, B, what percentage of kittens would have tan fur if a tabby cat is crossed with a black cat? Okay, let's just write this for a sec. So, crossing a tabby cat with a black cat. So let's go again with our alleles. Let's say C, T, no. What are our options? Tan. Okay, that's tan. and this C black, CB is black. So now we set up for the rest of our answer here. Do our Punnett square. Okay, so we have a tabby cat. The tabby phenotype is caused by a heterozygous genotype. So tan, black. Remember this T here is standing for tan, not tabby. Okay, do not get confused with these letters because they can quickly lead you astray. Okay, so that's our tabby cat crossing with a black cat. C black B. Okay. So I don't know if you've noticed, but I typically will put this organism first. So whatever, if I see this one first, tabby cat, I'll put that up in the top. Okay. That's just how I do it. As long as you're consistent, it'll help you with your setup. Okay. So that's just how I've been doing these for years. So that's just how I do them now. So tabby cat crossing with a black cat. Well, let's just do this. C, T, C, B. This one gets a C, B, C, B, C, T, C, B, and C, B, C, B. Okay, by the way, the C, why I'm choosing C is because the trait is color. Alright, what percentage of kittens would have tan fur? That's all I want. So let's do our quick genotype analysis first. So G type. Okay, so what do I have? I have 2 of these CB for every 2 black cats. So 2 tabs, so 2 heterozygous to every 2 homozygous black. Okay, now what percentage of kittens would have a tan fur? Well, remember, to have tan, so I'm going to write this out as an answer. So okay, we've already answered A. This is B. This is all answer to B. What I would write is that the tabby, again, this depends on how many points the question is worth. Tabby fur, so we want tan fur. Tan fur caused by CT. No CT. Oops, no CT in a possible sorry, Stars is dying on me. No homozygous tan is possible from this pairing. Oops, I'm going to move over here now. So I'm over here. Is not possible from this pairing. So percentage of offspring with tan fur with tan equals 0%. And that's my long-winded way of answering this question. Like I said, depending on how many points this question is worth, you will adjust the length of your answer. If it's just a 1-point question, you can just write 0%. Okay, it's down here, 0%. Okay, but if it's like a explain or I state the percentage and justify your decision or anything like that, or if it's worth 2 or 3 points, you want to start incorporating more of this working out and a longer explanation. Okay, so I hope that clarifies some things about incomplete and codominance.